Compiler Design Unit 2 for RGPV Exam 2023 notes are in the comments section. Syntax analysis, also known as parsing, is an essential phase in the compilation process of programming languages. It aims to analyze the structure of the source code based on a given grammar, usually represented by a context-free grammar, CFG. This note will explore different aspects of syntax analysis, including CFGs, top-down parsing, the brute force approach, and recursive descent parsing. 1. Context-free grammar, CFG. A CFG is a formal notation used to describe the syntax of a programming language. It consists of a set of production rules that define how valid sentences can be formed in the language. A CFG consists of a set of non-terminal symbols, terminal symbols, production rules, and a start symbol. 2. Top-down parsing. Top-down parsing is a parsing technique that starts from the start symbol of a CFG and attempts to construct a parse tree from the top, root, to the bottom, leaves. It uses a set of parsing rules to expand non-terminal symbols into terminal symbols, matching the input string. Common top-down parsing algorithms include recursive descent parsing and LALR parsing. 3. Brute force approach. Brute force parsing is a naive approach to parsing that explores all possible combinations of productions until a valid parse tree or error is found. It exhaustively applies all production rules, backtracking when necessary, until a valid parse is obtained. Brute force parsing is highly inefficient and not suitable for practical use due to the exponential growth of the search space. 4. Recursive descent parsing. Recursive descent parsing is a top-down parsing technique that uses recursive procedures to match the input string with the productions of a CFG. Each non-terminal in the grammar corresponds to a parsing procedure, which recursively invokes other procedures based on the production rules. Recursive descent parsing is easy to implement and understand, especially when the CFG closely resembles the structure of the programming language. In the field of compiler design, the transformation of grammars and different parsing techniques play a vital role in the syntax analysis phase. This note will delve into the transformation of grammars, predictive parsing, and bottom-up parsing. 1. Transformation of grammars. Sometimes, the original context-free grammar, CFG, may need to be transformed into an equivalent form for efficient parsing or to meet certain requirements. Common transformations include removing left recursion and left factoring, which help eliminate ambiguities and improve parsing algorithms' efficiency. Left recursion removal involves rewriting productions to avoid recursive calls that lead to infinite loops during parsing. Left factoring is a technique that combines common prefixes of alternate productions into separate non-terminals, reducing the number of choices during parsing. 2. Predictive parsing. Predictive parsing is a top-down parsing technique that uses a recursive descent approach with a lookahead to choose the correct production rule to expand. It requires a modified form of a context-free grammar known as the LALR grammar, where L stands for left to right, leftmost derivation. The K in LALR refers to the number of lookahead symbols used to predict the next production rule. Predictive parsing constructs a parse tree by recursively expanding non-terminals based on a fixed, predetermined parsing table constructed from the grammar. 3. Bottom-up parsing. Bottom-up parsing is a widely used parsing technique that constructs a parse tree starting from the leaves, tokens, and working upwards towards the root. It is more general than top-down parsing and can handle a broader class of grammars, including ambiguous ones. Common bottom-up parsing algorithms include shift-reduce parsing and LR parsing. Shift-reduce parsing involves shifting input symbols onto a stack and then reducing them based on production rules until the entire input is reduced to the start symbol. LR parsing is a more efficient variant of shift-reduce parsing that uses a bottom-up deterministic finite automaton, LR parser, to recognize valid sequences of grammar symbols. 1. Operator precedence parsing. Operator precedence parsing is a bottom-up parsing technique that uses the precedence and associativity of operators to parse expressions. It builds an operator precedence table based on the grammar, which specifies the relationships between operators. The table defines the order in which operators are processed, resolving shift-reduce and reduce-reduce conflicts. During parsing, the input expression is scanned from left to right, and the parser uses the precedence table to determine the next action, shift or reduce, based on the current and lookahead symbols. 2. LR parsers. LR parsers are a class of bottom-up parsing techniques that can handle a wide range of context-free grammars. The LR stands for left to right, rightmost derivation, indicating the parsing direction from left to right and the construction of a rightmost derivation. LR parsers use a deterministic finite automaton called an LR parser to recognize valid sequences of grammar symbols. The LR parsing technique is more powerful than top-down parsing and can handle larger grammars and left recursive productions. 3. Types of LR parsers. A. SLR, Simple LR, Parser. SLR parsers are the simplest form of LR parsers. They use a simplified version of the LR, items, which are augmented with lookahead symbols, to construct the parsing table. SLR parsers have a smaller parsing table but may suffer from more conflicts and limited parsing capabilities. B. LALR, Lookahead LR, Parser. LALR parsers are an improvement over SLR parsers and have a larger parsing power. They use a more compact version of the LR, items by merging states with similar core sets to reduce the size of the parsing table. LALR parsers strike a balance between parsing power and table size, making them widely used in practice. C. LR parser. 1. LR parsers refer to the most powerful and general form of LR parsers. 2. They use the complete LR, items, which include both the core set and lookahead symbols, to construct the parsing table. 3. LR parsers have a larger parsing table but can handle a broader class of grammars without conflicts. 4. Parser generation. Parser generation involves automatically generating a parser from a given grammar specification. Parser generators, such as YACC, yet another compiler, or Bison, facilitate this process. Parser generators take a grammar specification and produce parser code in a target programming language. These tools automate the process of constructing the parsing table and generating efficient parser code, saving time and effort in the compiler development process.